I'm here today to talk about resilience in the warehouse automation. Specifically, I'm going to be talking about robotic side, but it's applicable across other forms of automation as well. But you know, that's where Plus One lives. That's where I've lived for the last 4 years. So we'll get started. I want to give a little background of me because I'll just burn through my history. I won't be as detailed as some of the other guys. But if you know Deming, you know Dr. Deming, you know Six Sigma Lean, you're going to know a lot about me because that's kind of how I view the world. I started as a process engineer and liked it and just kind of stuck there. But there are two basic rules for life. Change is inevitable. We see a lot of change in the industry right now, both with the adoption of robotics. You see crazy future stuff like humanoids, a lot of change. And everybody hates change, and they're going to resist you. A lot of points were made in the other topics about getting everyone on board and getting everyone committed to it. These things are true. They're going to happen, and we're going to talk about what can be done on automation that will make people happy that they committed to it. So, quick background. You guys can read that stuff. That's me at Automate a couple years ago. But you can read where I'm at, understand where I'm coming from on here if you want to have a perspective. And this is a question for the audience, so feel free to jump in and answer. It's not rhetorical. But if you were going to say that was resilient automation, or I want to buy resilient automation, any of these questions, what are the words you're going to use, or how are you going to describe resilient automation?
No breakdowns.
No breakdowns? Good call. You got one? No? Ashley? Anybody? Resilience?
Handles exceptions.
Handles exceptions. Withstands new technology, stays up there, future-proof. Those are all good. I'm a simple man. I have simple analogies, right? With business, if I pay for my stuff with your money, I have a business. If I pay for my stuff with my money, it's a hobby. I kind of think of robotics in a similar way. So I call resilience this. Green button, go to work. Red button, go home. Your operators are not buying the automation. The companies aren't buying the automation so someone can be around bot tending and helping it. Because people also don't generally understand why the robot did not just go pick the box off the pallet. Right? You can see my demo going here with depalletization and palletization. It wouldn't be obvious why that robot stopped working. If there's a box on the pallet, why didn't you go pick it? Why do we buy this dumb robot? It was expensive, it's in the way, and all these other negative connotations. What they expect is that they turn it on like a conveyor. They don't care that it's AI or robotics, that they turn it off and they're done and they go home. That's what resilience is in a nutshell to me. So Plus One has an approach in which I believe is an excellent way on how to achieve that in a highly variable world like logistics. It's called Yonder, the human in the loop. If you're familiar with us, you're familiar with this. If not, I can give you a quick rundown of exactly how it works. The robot is working on a pallet, taking things off, or picking things off a conveyor, or what have you. And I don't know, it tries to pick a box and doesn't get vacuumed. Well, what should you do? I don't know. You gave me a pick. It was bad. Call somebody. 2 or 3 seconds later, they say, yeah, pick the box here. Or like, yes, that isn't actually an empty pallet. Please move to the next pallet station. They just help it with that decision making where either AI failed or the physical system failed, and no one has to show up and help it. And generally what we've seen on our data is that is all it needs. Just answer its question once, I don't know, every hour or two, and no one has to show up. So here's my nice graphic. If you watch some of the webinars that Lisa and I host monthly, you would have seen this slide before, and you would have got the longer version of what I'm going to say here. But you need a good design. Ethan's talk was a lot about that, the design, the modular aspect of it. If you know all these problems exist, you've talked to your operators, you've talked to your supervisors, your maintenance guys, these problems are unavoidable. You're going to have to deal with those. You need to design the system that is capable of dealing with those to the best that it can be. So like right grippers, right vacuum pumps. Obviously, we have the AI vision, so make sure it's smart enough on the items, those type of things. It needs to handle them itself, right? Robot crashes, uncrash yourself and get back to work, that type of thing. But there's a whole lot of stuff that's just going to happen every once in a while. Maybe one every 10,000, maybe one every 20,000, maybe one every 5,000, or maybe it's just going to come in bulk. But people still just want it to work. A human in the loop is what solves that. Couple seconds, here's the answer, move on. Back to work. I don't know, 20 minutes later, I got another question. Here's your answer, move on. That creates green button, walk away, red button, go home. It doesn't mean that there's nobody helping it out. It means that the person helping it out is only helping it when they need it. They're not there, so the people on the floor can continue to do their job. And for the visual learners like myself, here's a video of our crew chiefs in real time. If you don't believe me, you can watch the timer at the top. I didn't speed this up. It's very easy for people to make these decisions. This one was basically the AI says, I got a whole pallet and I got an item. I can't have an item and a pallet together because I shouldn't have an empty pallet there. This doesn't make sense. I'm confused. This one says, looks like an item, but also just looks like a pallet. Well, someone fixed it with 2x4s. The crew chief can easily see that and say, yeah, that's empty, go. This application is actually just where it's too risky to go autonomously. We have a photo eye. If that photo eye is ever blocked, you call Yonder. So there shouldn't be anything there. Maybe you can go pick it, maybe not. But these are the real-time types of things that we see that need a decision to be made. And a person can make it in the amount of time that you're watching here very quickly, and the robot gets back to work. And again, from our webinars, this is real data. You can look at some of our marketing around here and some of the things that we're able to show you on our brochures and data sheets of our applications out in the real world that customers bought and they use every day. They do a real job at a real place for a real customer. Maybe they've scaled them through their network. They expect them to work. Just like when they buy a sorter or a conveyor or, I don't know, a door lock. They expect when they lock the key that the door locks. They expect the same from our systems. You can look through the numbers here on the slide, but I want to point to this one down here at the bottom primarily. This is on, let's say, 60 second, which is pretty nice, intervention rate. Our customers still had to pay employees $750,000 to help these robots do their job, like, in this last year on these 60 systems. We're not happy about that, but, it is what it is. Sometimes things are really stuck and the robot can't fix them. It happens. But if they did not have Yonder and they had to answer every one of those 3.8 million Yonder calls with a person on the floor because the robot stopped, they would have spent $15 million. I don't know exactly how much it is to install 60 robots. We could say it's 30 million. We could say it's 40 million. Really doesn't matter if you're spending $15 million a year keeping them running. Not a good purchase. This is human in the loops. Real bottom line impact. The value that it brings is not just a theoretical. It's a bottom line dollar value. And these are some pictures, again, for our visual guys. This is real stuff from Yonder, where they called abort. Said, sorry, robot, don't go. You can't pick up all these putties. You took the lids off all these bottles. Like, now you're going to pick up the bottles. Like, you just have to stop. A pallet got jammed up on an exit. The other one, I know, the slip sheet up there, we tried to pick it. I talked to the crew chief, tried to pick it 3 times. Can't pick it. Apparently, it was stapled. Apparently, it was just stapled to that pallet. But that pallet's also not supposed to get auto pallet stacked. So, abort, right? Don't proceed. The decision, just a quick decision. So when people show up, it's actually a problem that a person needs to solve, not just something the robot was confused about. And that's what I got in my 10 minutes. Any questions, any comments? We're good?
How many staff are there responding to calls?
It's a good question. So how many people do we have on a crew chief? I don't know for sure the exact number, but I know it's enough that every, say, hour of the day, there's an escalation process with, I don't know, maybe it's 3 or 4 people that are lined up, and then that can escalate out to our customer excellence team, and then Ryan can get pinged on his phone to have to answer Yonder calls. And if it gets bad enough, I don't know, they wait like 3 minutes to get a Yonder call return. Eric has to do it. And so far, Eric has never had to answer one, so we get them answered quickly. I don't know exactly how many people it takes, but we keep it staffed 24/7 just because of the distribution of our systems across the world and the time zones. We got 24/7 coverage. Thank you, guys.